Hello friends, good evening. Let's continue the structure analysis 1, right? Dear friends, this is lecture number 3. We solved some questions of UPTU. The question was asked in examination, not so important. Question was enlist various methods of analysis of trusses. Right? I have marked the questions 2 star, 3 star or 4 star. 4 star questions are most IMP and you have not to skip any question which is 4 star mark, right? 3 star are also most important, but they are little bit lesser than 4 star questions, so you can leave some of 3 star questions, but 4 star questions are mandatory to be solved in the examination, right? And 2 star questions are rarely asked in the examination, but if you solve all the questions 3 star, 4 star and 2 star, no question will be out of scope of these notes, right? So what are various methods? So methods are: number 1, method of joints; 2, methods of section; 3, method of tension coefficient; 4th is graphical method; 5th is matrix method; and 6th is unit load method oblique method of substitute members, right? Method 1 is method of joint. You have studied method of joint. In this method we cut a joint and write the equilibrium of joint. For example, I have cut here joint B. I have cut here joint B, and after the cutting, as soon as we make any cut in the structure and separate a small part of structure, we have to show all the forces in the cut members, right? For example, member BA has been cut, so member BA one axial force should be shown because all the truss member carry only axial force. So let us force is FBA, right? Force is FBA, and FBA and you will show all the forces only in tensile, right? You have to show all the forces tensile. So you have shown tensile force FBA, and in member BC you have shown member forces FBC. Okay, you have shown member forces FBA and FBC. Now in 2D truss you have only two equilibrium equations, summation fx0 and summation fy0, right? So I will resolve these forces in two direction. One is summation fx0 means force in this direction equal to force in this direction. So force in this direction is what? FBC sin theta, and in this direction is FBC FBA sin theta, right? One equation is, second equation is summation Fy0 means force in upward direction equal to force in downward direction. So force in upward direction is 0, but force in downward direction is 10 plus FBA cos theta plus FBC cos theta. Now using equation 2, third equation we cannot use because there is no use. All the three forces are concurrent. So if we take moment of all forces about point B, it will always be 0. So we cannot find out any unknown force using third equation. Hence in case of 2D trusses we have only two equilibrium equations, summation fx0 and summation fy0. However, in case of 3D trusses we have three equations, summation fx0, summation fy0 and summation fz0, right? Second method is method of section. Now we can solve these equations and find FB and FBC. If all the answers FB and FBC will be positive, means direction is as we have assumed, means force will be tensile, otherwise force will be compressive. Now second is method of section. Method of section, in this method we this is also the equilibrium method. We cut only this, we will cut only the small part of structure, but if in all the cutting members, all the forces are not concurrent. For example, I have make a cut here. See, I have make a cut here. So I have made a cut here. So at this joint, three members will cut BA, DA and DE. So I will show force FBA, FDA and FDE. Now I will separate this part. I have written this part here. These all the three forces are not concurrent, so we can use three equations: summation fx0, summation fy0 and summation mz0. Here moment equation can also be used, right? So also one precaution is taken while using method of section, that this is the limitation of method of section, that at cut at the section where you have made a cut, the unknown forces should not be greater than 3. Here unknown forces are 3, right? Unknown forces should not be greater than 3, right? Method of section is useful if we have to find a force in some a special member or some members, not in all members. For example, if we ask find out force in member AB, so we will cut the section in such a way that FAB, that member AB should mandatorily be cut, right? So then only we can show force in member B FAB. So force is FAB and this FDA and FDE. Now in order to find out FBA, however we can write all the three equations and find out all the three forces, but if we require only one force FBA, we can take moment of all forces about point D, right? We have to analyze this left part, not the right. We have to analyze only right part, not the left part. If we take moment of all forces about point D, so moment of DE will be 0, moment of DA will be 0, right? Because these two passes on from this point, and moment of tan is 0. Only we will take tan will rotate in this direction, so tan into 2 equal to FBA into this length, and this length is, this is 2, so this will be 1/2, so FBA into 1. So we can calculate FBA. This is the advantage of method of section, right? Okay, we will solve more questions. Let us see more questions. See here, method of section. Question based on method of section are usually asked in competition exams, GATE and IES, not in UPTU. So but I solve some questions. See, for example, this is the question. Find force in member AC. Find force in member AC. So I have to make cut in the member in such a way that member AC should mandatorily be cut, right? So I can make a cut like this, right? I can make a cut like this and find in force member AC, because if I make a cut like this, the forces will be FAH, FAB and FAC, and I have to find out force in FAC, but reaction should be known, right? Reaction should also be known. So first of all I should find out reaction, then I can make a cut and I can write down equilibrium equations, right? But if I cut the member here, we have three unknowns, 1, 2 and 3, and all the three unknowns forces are concurrent, and equation of equilibrium in concurrent forces are 2, so we cannot find out, so we cannot make cut here. We have to think some another option. Dear friends, if I cut member like this as shown, however cut member are 4, 1, 2, 3, 4, unknown forces are 4, but 2 are concurrent, so moment of these two will be 0, only 2 will appear, right? Only 2 will appear. So the two parts of structure will be like that. This will be FCH, FCH, this and this. Now I will take moment, right? I will take moment of all forces. However, I can write down the equation summation fx0, summation fy0 and summation mz0 for this part and this part, or either for this part or either for this part. But the convenient equation is summation of mz0. Means if I want to take moment, this is the question of gate, or also the question was asked in engineering mechanics first year, right? So if I take moment about point D, look here of this part, if I will analyze this part, I can write down the equilibrium of this part or equilibrium of this part. If I write down the equilibrium of this part, I need the external reactions also, but if I do not want to find a reaction, I should analyze the upper part. So how, if I take moment of all forces about point D, moment of this will be 0, moment of this will be 0, moment of this will be 0, only 1 2 3 will there. So FCA will rotate in this direction, 10 will rotate in this direction, 20 will rotate in this direction. So 20 into 3 equal to 10 into 6 plus FCA into 6. So this is FCA into 6 plus 10 into 6 equal to 20. About this point, FCA plus 10 and 20, right? So this is the question. Next question is this. Next question, this was the same question is asked in GATE and IES many times. He asked, find force in member AC, right? Find force in member AC. So always in this question, always remember, we make cut here, we will make cut here, right? AC is inclined member, so there is no point about which if I take moment and find AC. If I take moment about this point, if I take moment about this point, this B, about B, so the moment of this will be 0, but two unknown will be there, right? But if I take moment about this point, this, so the moment it will 0, but these two will appear, these two unknown. But friends, if I take moment about point E, moment of FCB will be 0 and moment of FDA will be 0. Only FCA will appear in my equation, and this P is known, P into this. So I will take moment about point E. But this force is inclined. First of all, resolve this force in two direction. One will be FCA cos this, means FCA by 2, and other will be FCA sin this, means FCA cos this means FCA root 3 by 2, and it will be FCA sin this means FCA by 2. So moment will be this will rotate in this direction, P. So P into this distance is what? Is it given? It is given A. So P into A in this direction, and this is 0, this is 0. FCA cos this in this direction. So FCA cos this into this distance. This distance I can calculate by geometry. It will be A by root 3. If it is this is A, this is 30, this is angle 60. See how are the distances? This is A, means this is A. I can find out this distance, I can find out this distance. This is 60, this is 60, this is 60. All these three dimensions will be same. I can easily find out, right? So if I take moment about this point, it will be FCA cos this into A by root 3, and plus one component is this, other component is this, FCA sin 30 into this distance A equal to P into A. So I can find out FCA equal to P, right? However, it can also be find out using method of joint also. You take joint here, find out force in this and this. Now take joint here and joint here, right? We can also find out. I have solved here using method of joints also. I have written here what I have written. Look here. Similarly, we can find FBC by taking moment about A. If I take moment about A, moment of FDA will be 0, moment of FCA will be 0, only one unknown will be FCB, right? Similarly, we can find out FAD by taking moment C. About C, if I take moment about C, these two will be 0 and FDA will be answer, right? Same question can also be solved by method of joint I have solved here, right? One question is this. See this question. He says find out force in all members, or sometime he says find out force in some given specific member. See, dear friends, while using method of joint, at any joints member unknown forces should not be more than 2. But here at every joint more than 2 members, that is 3 members are connected, problem cannot be solved by method of joint. But since truss is determinate, ds equal to 0 means truss can be determined. So how can we determine? Let us see. Dear friends, if I make a cut like this, look, make a cut like this, the structure will cut in this way. Unknown force is 1, 2, 3, 4. But these two are concurrent, so unknown are 2 only, right? So how can I find out? If I take moment about point, or I can easily write equation of equilibrium also, uh, fx equal to 0 if I write, so FEF, force in this direction equal to force in this direction, FEF equal to 0, this is 0. Now summation Fy means FAB plus FCD plus 1 equal to 0. And third, moment about point G. If I take moment about point G, moment of this will be 0 and moment of this is already 0. So I can take 1 into this distance plus FCD into this distance equal to 0. 1 into this distance plus FCD equal to this distance. 1 into this distance plus FCD equal to this distance equal to 0. So FCD and FAB. Now further, using method of joint, we can calculate force in all members, right? Okay. Dear friend, it is time. Next, this is now most important topic for UPTU and IES, truss analysis. Dear friends, truss analysis. First of all, truss is a pin jointed frame in which all the joints are pin connected or hinged. All the members of truss carry only axial load, bracket में shear force and bending moments are 0. What are the assumption in case of trusses? First assumption is all the joints are pin connected, loading is applied only on the joints, and weight of members is negligible compared to the member force. Hence we can assume member as weightless. Under the above assumptions, we can say that there is no bending of truss member, hence truss member will carry only axial force, shear force and bending moment in truss member will be 0, right? How to analyze the trusses? Method of analysis are method of joints, method of section, method of tension coefficient, method of substitute member. We will study all the 4 methods, right? So first method is method of joint or method of section. We will see together. So question 1, this question is frequent in UPTU. Question was asked 2 or 3 times in UPTU, so I have written most important. So let us see. Dear friends, first of all, while analyzing the truss, we will calculate DSE and DSI. DSE is reaction, this is hinge, it is roller. So 2 plus 1, 3. RE equal to 3. So RE minus 3 equal to 0. So DS will be, DSE will be 0. Means external indeterminacy is 0, means external equation, external reactions can easily be counted or can be uh, determined using equation of static equilibrium only. Second is DSI. DSI is m minus 2j minus 3. Members are 5 minus joints are 4. M minus 2j minus 3 equal to 0. Means DSE is 0, DSI is 0. Truss is determinate both internally and externally. So truss is determinate. Hence at hinge C, two reaction. So truss is determinate. Now how to find out reaction? At hinge C there will be two reactions, and at hinge D it is roller support, it will be one reaction only. These are two reaction, it will be one reaction. First aim is to calculate the reaction. First aim is to calculate the reactions. See how we will calculate reaction. Look, let us suppose two reactions, one is VC, one is VT, and one is HC, horizontal reaction at C. Dear friends, since force is in this direction, so we can assume that reaction will be in opposite direction, so we can take direction. However, we can take direction in this direction also. Answer will be negative, but in case answer will be positive. See, use equation 1. Summation fx0 means force in this direction equal to force in this direction. Force in this direction is hc only, and each direction is 8. So hc equal to 8. Now second equation, vc plus vd equal to 16 means summation fy equal to 0. So it will be vc plus vd equal to 16. Downward equal to upward force. Third equation, summation mc equal to 0. Let us take moment about point C. So about point C, Vd into 6 in this direction, whereas 16 into 3 in this direction, and 8 into 4 in this direction. So I have written this equation. We can find out Vc and Vd. Now we will solve the truss. Since we have to find out force in all the members, so we will solve the truss using method of joints. We will start from that joints which have minimum members. So joint C and D have only two members. So let us start from joint C. But before starting, we will calculate these angles theta and alpha. So we can calculate using triangle AEC and BCE. What is tan alpha and tan theta? We can, but we will use only sin alpha cos alpha or sin theta cos theta. So we calculate sin alpha sin theta, cos alpha cos theta. Now take joint. Dear friends, before starting the analysis, let us see this thing. Yeah, this is. In case of trusses, if this is a truss, this is A, this is B, this is C, right? Some loading is there, right? If I cut this joint, this means I will show this is reaction RA, this is HA. So joint A, I will show HA, let us suppose 10, RA, let us suppose 20, right? So now this is joint A. Member force, I will show member force at joint. This will be FAC and this will be FAB. Remember, this is force on joint. This is force on joint, and I have shown force on joint. We always show force on joint and calculate force on joint, but we have to find force in member. If we see, force in member is same as force at joint in the same direction. Let us see. Equilibrium. This is FAC, it will be FAC. This is FCA, this is joint C, it is FCA, FCB. See friends, if joint is in tension, member will also be in tension. So we can solve only joint. We can solve only joint and show force in member in same direction. So we solve by taking joint equilibrium and calculate force on joint, right? And so same force in the members also, right? So we will calculate FAC and FAB. If it is positive, means joint is in tension, hence member will also be in tension, and we will show force. Finally, in member, we will show force like this. For example, FAB is 5 and FAC is -3. Now, 5 means member is in tension and joint is also in tension. This is A, this is B, this is C. So we will show joint is in tension. This is joint in tension. This joint is also in tension. Member will also be in tension. This is member is also in tension. This is also 5. This is also 5. Since FAC is negative, means joint is in compression. So force on joint in compression. For joint, this joint will also be in compression. Member will also be in compression. See, member is also in compression. So it will be 3. It will be 3. This is the way of representing force in truss members, right? Let us solve the questions. Solve this question, right? Okay. So now we will consider joint C. At joint C, two members FCB and FAC. Now this is theta, this is alpha. At using in method of joint, we have only two equations, summation fx0 and summation fy0. We write summation fy0. Summation fy0 means y direction, up equal to down. But up force is 2.67 plus FAC sin theta is 4 by 5 plus FCB sin alpha 2 by root 3 equal to 0. Equation 1. Summation fx0 equal to force in this direction equal to force in this direction. In this direction only 8. In this direction FCB cos alpha plus FAC cos theta. Using these equations we can find out FCB and FAC, right? So we can find out in this and this. Now we will take joint D, because minimum members joint D. Similarly, this is FBD and FAD. We can find out force in this. Now we will take joint B. At joint B, FBC, FBD and FBA. BCBD we have already calculated. FBA we can find out FBA, right? Now, so we have calculated force in all members using only joint 3, right? Page 16. This is page 17. This is the way of representing force, right? You will write member, you will write forces. Now you will write again force without sign and with their nature. Plus means tensile, negative means compressive. This question was again asked. Let it see. This is 54 force horizontal. This calculate member forces. So we can solve in as earlier case. I want to tell you only reactions. How to find out reaction? This will be 54 and summation of up will be 0, because VA plus VB. This VA plus VB equal to down means 0, and moment about this point equal to 0 means VB into 9 equal to plus 54 into this equal to 0. So VB will minus means direction is downward, VH plus means direction is up. VB, right? So we can solve this, right? Okay. I have written answers. See, note that in case of loading is symmetrical, if loading is symmetrical, force will also be symmetrical. Means force in AC equal to force in BC, force in AD equal to force in BD, right? Okay. this page 18. Analyze the truss using method of joint or method of section. So we will analyze the truss using method of joint. See, method of joint. First of all, the force is inclined. Force is inclined. So we will resolve force in two direction. Tan cos 30, tan sin 30. One will be 5 root 3, other will be 5. Right? One will be 5 root 3, other will be 5. Now we will, since it is simply supported truss, we will calculate first reactions. This is HA, this is VA, this is VB. Up equal to down, this direction equal to this, and summation of moment about A equal to 0. Since this is 4, this is 4, this is 60, 60, so it will also be 60, it is 4, it will also be 4, because this will be similar triangle, so all sides will be 4. Right? Okay. So now, how can we calculate? We can start from any joint, either A or B, because on A and B joints only two members are connected. So I have started from joint A, 5 in this direction, this is upward direction, this is FAE and FAC. We can resolve, right? So we can take further joints and solve easily. I have solved all the questions, right, and shown final answer, right? I have shown final answer. Next question. This is important question. It is asked 2 times in the examination. So the truss is given, angles are given. Calculate force in members, right? So first aim is to calculate the distance CF and DG. So we can easily calculate. It is a similar triangle. In similar triangle, perpendicular equal to root 3 by 2 into side. So perpendicular means FC equal to side into root 3 by 2. What is the side? This is 10, this is 10, this is 60, this is 30. So it will be, this will be 90. So it is right angle triangle. If it is 10, so this side will be 10 cos 60 and this side will be 10 side 60, right? So it is 10 cos 60. So this will also be 10 cos 60 because this triangle is similar triangle, right? So AC will be 10 cos 60, right? And these all sides are equal, so it will, these all will be 5, this 5, this 5 and this 5, right? Okay. Now FCB equal to 10 sin 60. This is 90 degree na. This is 90, it is 10. So this will be 10 cos 60, this is 60, and this will be 10 sin 60, right? 10 cos 60 and 10 sin 60. So while calculating the angles, so we can further proceed. I have calculated all the distances which I required, means FC, DG, right? I have calculated, and reactions. Now we can start from any joint. This is joint A, this is joint A, right? This is joint A. So now we can proceed further. At joint A we can write down equilibrium. Force in this direction equal to this direction, up equal to down, we can find out, right? Now this joint B, we can proceed. I have taken this joint E, this is joint E, right? I have shown all the forces, and similarly we can find out. Dear friends, important thing is that in trusses we can calculate member of zero forces. There are some direct observations by using which we can find out force in truss members by general observation. See, what are those instructions? First of all, first point is, if at any joint there is no loading, if at any joint there is no loading and two members are connected at this joint, for example, this is joint like this, two members connected, no loading at joint B, this is A, this is C, force in both members will be 0 if theta is not 0, right? If theta is not, theta may be any, so if in this case force FBA and FBC will be 0. Why? Because if I write equation, this is FBC, so FBC, this is FBC cos 30 cos theta, and this is FBC sin theta, so FBC sin theta equal to 0 because up equal to down, up is FBC sin theta and down is 0, so FBC is 0, and once FBC is 0, so FAB will also be 0 because FAB plus FBC cos 30 cos theta equal to 0 and this is 0, right? So in these two members force will be 0. Point 2, if at a joint there is no loading and three members are connected, of these three members two members are in straight line, two members are in straight line, then force in third member will be 0. For example, this third member may be in any direction, this is A, B, C and D. So if this is the arrangement, force in this member will be 0. We can prove also how. If this is FAD, so this is FAD cos theta and this is FAD sin theta. FAD sin theta equal to 0 because no force in downward direction, hence FAD equal to 0, right? So FAD will be 0 and force in two straight members will be equal FBA या FAB equal to FAC. This is the second observation. Third, if this is the joint like this and this is the force P, this is A, this is B, this is C, so we can say that this entire force will be taken by AB only because force in AC will be 0. Reason behind is that upward equal to downward, upward is 0 and downward is FAC, so FAC equal to 0 and left equal to right, hence FAB equal to P. So if it is compressive force, so force in member AB will be compressive, FAB compressive, so I can say FAB equal to minus P, right? FAB equal to minus P. Similarly, number 4 point, if rectangular joint is there, this is 10, this is 5, this is A, this is B, this is C, so force in AB will be 5 tensile, tensile is taken as positive, and force in AC, FAC is 10 and 10 compressive, so minus 10, right? Okay, now further, number 5 points, if 5 points will be, what can be the different arrangement, like this. See, this is the arrangement. Now no observation for this, I just search where is the page on which I have written the member force in 0. Yeah, one more point is there, this, if this is the rectangular arrangement and loading is like this 10, in this case Summation fx 0 means this force equal to this. If this is A, this is B, this is C. Means FAB equal to FAC and FAD equal to 10 compression means minus 10. This is also direct observation. Right. Okay. One or two question we solve, one or two question of gate. This question was asked in gate. Look. Question was like this. He asked find out member of zero force. Okay. So member of zero force, in order to search, we have to see only those joint on which loading is not applied, right? And on those joints on which loading is not applied, two or three members should be meet. Listen, see this joint. At this joint, three members are there, and is at this joint no loading is there. Hence, force in this member will be zero because two are straight and one is at an angle. So force in this will be zero. Once the force in this will be zero, now at this joint I will see these two are straight and force in this member will also be zero. Here these two are straight, so force in this will be zero. Once force in this will be zero, I can remove this. Now at this joint member will be 3, force in this member will be 0, right? Also, now see this joint. Now at this joint only two members are connected and no loading at this joint, so force in this and this will be 0, right? Now also force in this member will be 0, this member, right? Because this is no member, there is no member here, so only this member and this member, so the entire P force will be in this member, so force in this also 0 and this is same member, force in this will also 0. So member of 0 force are 1, 2, 3. Also force in this member will be 0 because by this joint we can say that at this joint 3 members, so force in this will be 0 and force in these two members will be equal. So if force in this member is 0, so force in this will also be 0. So forces are 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 members, right? 9 members. Okay. Let us solve some questions of UPTU. This question, this is most frequent question, most IMP and frequent question in UPTU. See, he says find out force in all the members. Find out force in all the members. Now, by direct observation, we can conclude some points. What are those points? We can say that at joint E, 3 members are connected to EC and EA are straight and ED is at an angle, right? So force in member ED will be 0 and force in EC and EA will be equal. Now if force in ED will be 0, now we can remove ED, so at joint D now there will be 3 members only, and at joint D there are 3 members, 2 are parallel and one is at an angle, so force in AD will be 0, so we can remove ED and AD. Force in CD and CB will be equal. Force in CD and CB will be equal. So we can write truss as this. Remove these two members. Now we can analyze by taking joint C. I can find out by taking joint C. I can find out, or I can start from this joint. Direct observation, because this is 10 force. I can calculate for reactions VA, VB, HC, and if I take joint A, in joint A by direct observation, I can say that force in AE will be VA, and VA is minus 26.67, means VA is tensile. VA is tensile, hence force in AE will also be tensile. So FAC equal to tensile 26.67, means plus 26.67, and same force will be in EC. So FA equal to FEC, right? Because at joint E, two members are straight and one was at an angle, so force in that angle was 0, and FEC and FEA are equal, right? So by this, force in this and this are equal, and force we can calculate this. Now we can take joint B. Joint B, this angle is alpha. We can find out alpha, and by taking joint equilibrium we can find out FBD, right? Okay. Question. Analyze the truss. Analyze the truss. Dear friends, it is cantilever truss. We need not to find out reactions. We need not to find out reaction. We can start from joint C. Start from joint C. This is joint C. Also by direct observation we can say that force in BD will be W tensile, means FBD will be plus W, right? This is FBD equal to plus W. FBD equal to plus W. So we can take joint, first of all joint C, then joint D, and then joint B, and finally A or E, right? Okay. Next question. Analyze the truss. So it is simply supported truss. First of all, find out reactions. Once we found out reaction, now by direct observation write reaction. VA equal to 25 plus, means direction will be same as we assumed, and VB equal to plus 45. See, at joint A, this is tensile force 20 outward, means FAC will be 20 tensile or plus 20. So FAC will be plus 20, and FAE will be 25 compressive, means minus 25. FAE will minus 25. Now this is joint A over. We can take joint B. Joint B, FBD equal to 45 compressive, means minus 45 by direct observation, and FCB equal to 0 because in this direction no force, right? Now we can take either joint C or joint or and also at joint F. At joint F, FAC equal to 70 compressive, means minus 70. Now we can take different joints and calculate forces in other members, right? Similar question is this question was asked, so this is also important. First of all, find out reaction, and by direct observation or by using method of joint we can solve, right? What are the direct observations? This is 20, this is 25, this is 45. So at joint A, means force in AC will be 20 tensile plus 20, and force in AE will be 25 compressive, means minus 25, right? Similarly at joint B, FBD equal to minus 45 means 45 compressive, and this will be 0. And also here at joint F, a force in FFC will be 70 compressive means minus 70, right? Okay. See next question. Analyze the truss. Okay, there are two supports A and C. So first of all, we have to find out reactions VA and VC and HC. So upward equal to downward means this VA plus VC equal to 400, and HC equal to 600, and summation of moment about any point should be 0. There is no direct observation. Yes, we can take observation at joint C. At joint C, force in BC will be equal to HC. So force in BC, HC is plus or minus, HC is plus 600 plus 600. It means force in FCB equal to 600 compressive means minus 600, and force in CD equal to VC is minus 200 means 200 compressive. So force in CD equal to minus 200, right? And now by taking the other joints, we can find out force in different members, right? Next question. This is the question. Find out force in AB, AF and BC. This is AB, AF and BC, right? Either we can use by method of joint or method of section. So we let us solve by method of joint, and we can find out force in all members. Okay.